This is a continuation of the second part of the video that I made concerning polynomial equations. In that video we saw how we can solve polynomials of next higher degree in terms of polynomial of a previous degree, and there is a pattern in their solution. So for a quadratic equation we make use of the fact that a minus b the whole square is equal to a plus b the whole square minus 4ab. Likewise, for the cubic equation, we make use of the fact that a minus b the whole cube is equal to a plus b the whole cube minus 2b times b square plus 3a square. Now, by making use of this, we can obtain a quadratic equation, but only one of the roots of the quadratic equation, which you can test out, will be the solution for the cubic equation. If you know the solution, one solution for a particular cubic, for a particular polynomial, you can find other solutions in terms of its by making use of this fact. There, where again we will obtain. So if let alpha plus alpha dash be the solution to another solution to the same cubic equations. We have obtained one solution, alpha. Then we require a times alpha plus alpha dash the whole cube plus b times alpha plus alpha dash the whole square plus c times alpha plus alpha dash plus d is equal to a times alpha cube plus b times alpha square plus c times alpha plus d. So d and d will cancel out, which leaves us with a times alpha plus alpha dash the whole cube minus alpha cube plus b times plus alpha dash the whole square minus alpha square plus c times alpha plus alpha dash minus alpha is equal to 0, which gives us alpha plus alpha dash minus alpha into a times alpha dash square plus alpha dash plus alpha square plus b times two alpha plus alpha dash plus c equal to 0. Assuming alpha dash is not equal to 0, this gives the following quadratic equation, which is a alpha dash square plus a alpha plus b alpha dash plus a alpha square plus 2b alpha plus c equal to 0. So the final solution for this will be alpha dash equal to minus of a alpha plus b plus or minus square root of a alpha plus b the whole square minus 4a times b alpha minus d by a whole divided by 2a. So alpha plus alpha dash will be another. Each value of both of these values can be added to alpha for the cubic equation to obtain the other two roots. So if we know one root of a polynomial equation, we can obtain the other two roots as well. So similarly, for if we can solve a cubic equation, we should be able to solve a biquadratic equation in terms of a cubic equation. There again, we will have to make use of the fact for the biquadratic equation a minus b whole power 4 is equal to a plus b whole power 4 minus 8 times a square plus b square times ab. For the biquadratic, you have to make use of this formula to obtain one. Thereafter, you will obtain a cubic equation which can be solved using the method for the cubic one. So higher degree equation can always be solved in terms of equations of lower degree. Now, look at another approach also, but it turns out another line of thinking. I was looking at, in general, if f of x equal to 0 is true, then x times f of x is equal to 0 will also be true. X will be a solution, provided x is not, f of x times f of x will be equal to 0 will also be true. Suppose f of x is a polynomial or an expression, a polynomial without the constant term, and f of x equal to 0 is true. Then if we wish to find the solution x dash f of x plus c for the expression f of x plus c for the polynomial f of x plus c, then we need to determine x dash such that f of x plus x dash equal to f of x minus c. Then x plus x dash will be the solution to f of x plus c. But this gives us x dash is equal to f inverse of f of x minus c minus x. So we need to find the inverse of a function. So my thinking was, if we can find the inverse of a quadratic function, quadratic polynomial, we should be able to find the solution for a quadratic polynomial without the constant term or with the constant term also after adding it. Then we should be able to solve any polynomial of any degree if we can find the inverse of the polynomial expression, polynomial equation for it. So as it turns out, the inverse of to find the inverse of a quadratic polynomial, you have to solve a quadratic equation itself. So let's look at it, but even then we can find inverses in the same way. So one has to independently solve polynomial equations without making use of their inverses. Then let g of x be ax plus b. Then g inverse of x will be equal to x minus b by a. Let f of x equal to x times g of x. Okay. Assume that okay. Then we will have g of f inverse of x is equal to x by f inverse of x, and f of g inverse of x is equal to g inverse of x times x, or f inverse of x times g of f inverse of x is equal to f of g inverse of x over g inverse of x. This gives f inverse of x times g inverse of x times g of f inverse of x equal to f of g inverse of x over g inverse of x. Which gives f inverse of x times g inverse of x times g of f inverse of x equal to f of g inverse of x, which gives you f inverse of x times g inverse of x times a times f inverse of x plus b is equal to f of g inverse of x. Which gives me a times g, which gives this g inverse of x into f inverse of x the whole square plus b times g inverse of x times f inverse of x minus f of g inverse of x is equal to is equal to 0, which gives f inverse of x is equal to minus b plus root minus root of b square plus 4ax by 2a. We must remember that here f of x is equal to x times g of x. So we don't have a constant term there. We have to add one more constant term. So we also know that if suppose if f of x equal to g of x plus c, then f inverse of x is equal to g inverse of x minus c. Therefore, for the f inverse we found earlier, we have to replace x with x minus c. Therefore, if f of x equal to ax square, if f of x equal to ax square plus bx plus c, then f inverse of x will be equal to minus b plus or minus square root of, then f inverse of x will be equal to minus b plus or minus b square plus 4a times x minus c whole divided by 2a. You can check or verify that this is f inverse of x is indeed true by verifying f of f inverse of x will be equal to x. So this will always be true. x will always be equal to x. So this is the polynomial equation. So this is how we can, in a like manner, we can also find the inverse of a cubic function, cubic polynomial, and a biquadratic polynomial, and so on. Therefore, these can also be solved inductively.